Okay. I'm going to share the screen. Okay. Here we go. So, good morning, good afternoon, good night, everyone. And thanks for joining today for this webinar belonging to the Technical Talks of CTSoc series. Today, I will give a brief presentation of the technical talks, the technical areas of CTSoc and its technical committees. Then I will leave the floor to Dr. Paolo Napoletano, Professor Paolo Napoletano, and Professor Dixon Lee, who are representing two of our technical committees, who will introduce the speakers of today's talk. Just a brief introduction of CTSoc and the technical activity area. The technical activities is a new area that has been launched at the beginning of 2020 to manage and supervise the technical activities and the various areas that pertain to technical activities of IEEE Consumer Technology Society. Within this container, a number of technical committees have been created. In particular, we do have so far 15 technical committees, which represent broadly the various areas that are covered by IEEE Consumer Technology Society. Today, we do have the representation of two of these technical committees. One is the CCN, which is about consumer communication networks and connectivity, and MDA, which is machine learning, deep learning, and AI in consumer electronics. The technical activities areas is organized in the technical committees, as I said, and there is also a future directions committee, and these bodies are managed by the VP of Technical Activities, who is also responsible for chairing the Technical Committee Board. The CTSoc president is Wen-Chun Kao, VP Conference Nobuo Funabiki, VP Publications Fabrice Labo, who has also been recently elected as next president of CTSoc, VP Industry and Standards Activities Rahed Abdullah, and the 15 technical committees have each one its own chair, vice chair, and secretary. The Future Elections Committee, chaired by Fabrice Labo, has also 4 members: Professor Chen, Professor Sotelo, Professor Tapial, and Dr. Abdullah. Each technical committee has its own website. So you'll find the mission, you'll find the officers, you'll find the list of members and the responsibility of the technical committees. Here you have the officers for the current term. The term is 2 years, and we are starting the 4th year of existence of the technical committees in 2024. There is a possibility for new colleagues to join the technical committees. The enrollment now is continuous. We have a form on the website of CTSoc. There will be a QR code at the end of this presentation through which you can join the technical committees, and you can ask your colleagues to do that. And the new applications are periodically evaluated, and the new members are accepted into the technical committees. So far, we are approximately 900 members, which are a subset of CTSoc members, and include also people who is not a CTSoc member. So you don't have to be a CTSoc member to join the technical committees. As you see, there are different sizes, and there's continuous advertisement in order for new members to join. The responsibilities of the technical committees is to support the CTSoc in various areas: conferences, publications, standards, education, and industry, history, And so we are in charge of investigating, evaluating, promulgating and fostering new technologies and application, creating additional technical committees, and support the cross-cutting collaboration with other initiatives. There is a big initiative starting in the next month, which is called DRTC, the Digital Reality Technical Community, which is joining different societies, and you will hear more about that in the next weeks. The technical committees are involved in various areas, and for instance, regarding conferences, the technical committees are the core of the society because they're review and approve the call for papers for conferences. They support the conferences by contributing papers and reviewer. They collect, for instance, nomination among the members and recommend individuals for serving in the technical positions of CTSoc conferences as chair, workshop chairs, tutorial chair, publication chairs, and TPC members. They provide a conference track, the session chair, etc. Some example, we recently collected the technical positions in various conferences like ICC Las Vegas, ICC Berlin, Games, Entertainment and Media Conference. We run call for volunteers serving in associate editors positions for the journals of CTSoc, so Transaction and Consumer Electronics and Consumer Electronic Magazine. The technical committees organized special sessions in journal, special sessions in conferences. They participated in cross-society initiatives. They collaborated with the other non-IEEE societies like the Signal Processing Society and the Audio Engineering Society. They launched special interest group. They organized webinar and tech talks. So one of the next events will be a conference on gaming, entertainment, and media, which will be held in Turin. So it's a pleasure because it will be hosted by the university I'm working in. So this promotion is here because it's currently accepting submission, but also because it will be hosted at Politecnico di Torino in Italy. So coming to the last two slides, one of the initiatives that has been launched by the technical committees is the Technical Talks of CTSoc series, which is a series of webinars that originally were organized separately in some specific technical committees, but we decided to organize this as a periodic monthly event in which two speakers from two different technical committees with different areas typically intervene and present their research directions and their activities, their suggestions. And for this talk, we have invited the technical committee, CCN and MDA. So the technical committee on consumer communication networks and connectivity, and the technical committee on machine learning, deep learning, and AI in consumer electronics to invite two speakers representing their core topics. So I will leave the floor to the chairs and officers of these technical committees, Professor Paolo Napoletano for MDA and Professor Dixon Lee for CCN, who will introduce the speakers. I want to thank you for attending. I want to thank the officers for organizing the event, and of course I really want to thank the speakers for their availability, and I'm willing to listening their talks. Enjoy the talks, and of course if you're interested in joining technical committees, if you're not a member, here you have the direct link. Paolo and Dixon, the floor is yours.
So thank you very much. So good afternoon, everybody. Good night, good morning. So let's introduce now the first speaker of today. So thank you to Professor Yafei Hu, who is a senior member, IEEE senior member. So he received a dual PhD degrees from Fandon University, China, and Kochi University of Technology, Japan in 2007. And he was a postdoctoral research fellow with the Ryukoku University in Japan till 2010, and a research scientist with the Wave Engineering Laboratories ATR Institute International Japan till 2014. Then he became assistant professor at Nara Institute of Science and Technique in Japan in 2017. Then he moved to the Okayama University in Japan, where first he became assistant professor and now is his associate professor. So his research interests include communication systems, wireless networks, and signal processing. Today is going to talk about localization MIMO communication using leaky coaxial cables over linear cell environment. Thank you again, Professor Yafei Hu. So please start with your talk.
Okay, thank you, Chairman. And good afternoon and good morning, everyone. Can you see my PowerPoint?
Yes.
Yeah, perfectly.
Okay. And okay, thank you, everyone. And today I would like to introduce my research with the title as Localization and MIMO communications using linear coaxial cables over a linear cell environment. And in this short talk, I would like to introduce major in following three items. First, introduction on LCX, and then I will explain how to configure MIMO system use LCX, and then how to realize localization for LCX wireless system. And this figure shows the future wireless system. Here, just to give two simple examples. First one is a smart home system and smart flat environment. For the future wireless system, there are many technical requirements. For example, the first target for wireless system, they should consider realize a very higher transmit speed. And of course, for the sixth generation, the wireless communication, the perfect localization, location information is more important for many usage and wireless communication system. Of course, they have many other technology requirements, but today I would like to introduce the how to realize MIMO use LCX and how to realize localization use a cable antenna. And generally, for the indoor wireless system, they use an antenna as a monopole antenna, which like this, and then the radiation angle is they have no any specific direction. And for example, here I give an example for the indoor scalar. There are so many access points are located in the room, and then it can provide the stable wireless coverage. But of course, they have some problems. For example, for gigahertz single, they have a large power attenuation. And for configuring stable wireless coverage, they require many access points. And especially for following two environments, the first one is a manufacturing environment and the linear cell environment. Monopole antenna may be not so efficiency. For example, here given figure shows the manufacturer environment where there are so many metal objects. In such a case, shielding and the influence of the radio waves by metal barriers and objects are often occurs. And another case should be a linear cell environment like this tunnel. And this could be a long and a narrow space. And to keep the entire wireless coverage, they also need many access points. And generally, for these two specific environments, we can use another type of antenna. We call the cable antenna. This antenna can be called linear coaxial cables. And like this. And here, I give a very simple example to show how to use LCX to configure the wireless coverage. Here is one base station, and then the cable is connected to the base station, and then installed in room with any irregular shape. That means the cable can be bowed and extended and can be used for any irregular shape to configure the wireless coverage. And of course, there are some advantages like this. One is reduce the number of access points. Sorry. And another thing is can cover a varying area with a changeable shape. And the wireless signal is transmitted along the cable. In such a case, it can configure uniform coverage and simple installations. Due to these advantages, cable antenna can be used in many scale areas. For example, toners. In toner, usually cable antenna is often used. And of course, it can be implemented in factory. And recently, they are considered to use LCX for wireless for the underground environment. And we found some research shows that LCX, they can provide wireless power transfer. So next, I will give a simple introduction of how to use LCX for configure LCX MIMO. This figure shows the structure of LCX, which can 4 layers, and this is a indoor conductor, and then here is insulate, and then outer conductor, and then jacket. Over outer conductor, there are many slots, like here, this slot, and slot. And this slot can be used to receive a signal and transmit a signal. And more important property that for the same direction slot, they have a periodical distance we call the parameter P. This is a spacing among the slot. And the wireless signal can be transmitted and receiver use this slot, and then the signal is transmitted in this direction. I'm sorry. In this direction for receiver signal, and in this direction for transmit signal. And here I give an explanation for one important property for LCX. That means the radiation angle theta usually is decided by the slot space P, that's parameter P, and wavelengths. And this wavelength is decided by center frequency. So the radiation angle theta usually is just decided by the value of P. This means we can adjust the value P, then the radial angle theta can be changed. This is a very important property for cable antenna. And then the cable antenna can be used for wireless coverage like this, with single transmit to cable, and the slot radiates the signal to coverage stable wireless coverage, while provide the wireless coverage for this unit area. So till now, I have explained that conventional knowledge for LCX. So what's our contribution? And till now, they assume that each LCX cable is conventionally used as a one antenna. But our research is that for configuring MIMO system, at least 2 LCX cables are required. So we have a new way that whether we could use one LCX cable used for two antenna. We use that we use a property that I have explained, that we can find a good slot space P, and then we input the two singles in both sides. Due to the good parameter P, the radiation angle from different sides will generate indicate angles of two singles from two sides. Use this simple idea, each L6 cable can be used as two antennas. And here, two figures to show the main idea for the comparison between the conventional way and our proposed way. Conventional way, that means one LCX is used as one antenna, and our proposed way that by find a appropriate value P to adjust the radiation angle and including angle between two signals, we can, this is different type. This type is H-type LCX. This type is V-type LCX. We can find that for both type of LCX, one single cable can be used for two antenna. And in similar method, similar idea, we design a different P to achieve different radiation angle into different direction, and then combined these two different radiation angle, two LCX with different radiation direction, then we can realize a composite cable which can be used as a full antenna. This is our product, like here, like this. So let me give a demonstration for our proposed LCX. Sorry. Why they cannot be? Sorry. Okay. And this figure shows our measurement in the chamber, and sorry. I'm sorry. It's not so easy to. And the LCX cable is set in this place, and this way is the receiver antenna. Now this conventional LCX is installed and set here, and this is one receiver antenna here. And here shows the throughput. This is a conventional usage for LCX. That means one LCX used as a one antenna, and this is throughput. When this is a conventional LCX system, and the next, at this area, the throughput is not so stable. Now is our proposed method. That means one LCX cable, but the two input single at both sides. And we designed the radiator angle theta. We can find the throughput is largely improved. It's about double. And that means this measurement shows that our proposed method can be used as a two antenna. And okay. And let me give another example for 4x4 LCX MIMO. That means we use two designed LC cable used as a full antenna. That means that the up cable has a radiation angle as 55 degree, and the mark with 5V and 18 shows the angle degree like this. And then the 5V 50-50 shows the LC combo with radiate angle like these two figures. Use these two different LC combo, we can use it as a full antenna. Here we also give a measurement result and with these two figures. And this figure shows the average capacity comparison between the conventional 4x4 MIMO user monopolar antenna, and the capacity for monopolar antenna is shown with a red line, and our proposed L6 4x4 L6 MIMO is shown with a blue line, and the black line is the upper bound limitation. So we can find that our proposed methods can achieve better capacity than conventional monopolar antenna. Of course, it's in the temporal environment. In the real environment, maybe the difference between the L6 MIMO and monopolar antenna maybe not so large. Okay, next, I will give a simple explanation for how to use LCX signal to realize user localization. And this four figure shows the importance of perfect location information for users. And this figure shows the basic idea how we can use LCX to find the location of users. This is the transmitter with the location X and Y, and in a perfect environment, the wireless signal is first the signal will first transmit in the wireless path, and then through to the cable to arrive at this side. In a similar way, another signal can be in another side to arrive at the other side with time t2. And here, the relationship between T1 and T2 can be represented with these two equations. That means T1 and T2. And this part is the trans time with the wireless path and over a wireless path, and this is transmit time over a cable. With a known value C and epsilon, we can use a value of time difference arrival. That means the difference between T1 and T2, we can capture the value x-axis, and then use the theta. We can find the value of y-axis. This is the basic idea for localization using LCX. However, in the real environment, they will generate large localization error. The reason is that if theta is perfect, it's very easy to calculate the data TDOA. However, in the multipath fading, the theta will be a divergent value. In such a case, the TDOA will be like in this waveform. That means in such a case, due to a multipath fading, it's very difficult to calculate the TDOA. This will generate large increasement. So how to improve the localization accuracy? Our researchers have proposed three major methods. The first one, we wanted to use multi-LCX. And based on our research, we found that for LCX localization, the x-axis, which along the cable, the localization accuracy is higher than the y-axis. That means like this, localization error range seems to this shape. Of course, we can use another LCX cable in another way. and then we combine it using two LCX, but in vertical map. In such a case, we can reduce the localization area range like this. According to this idea, simple idea, we can use two LCX cable and to improve its localization accuracy. And this is a evolution result. And this music TDUA is a conventional way. That means this is a single LCX. These are proposed method use this vertical two LCX cables. And the x-axis is the localization error, and the y-axis is error CTF. That means in this area, we can have a better localization accuracy, and this area is a worse accuracy. And our proposal, this that use two LCX, it can easily improve its localization accuracy. Another method that we found that for LCX cable, because the signal is radiated from so many slots, and then the time series data of LCX RSSI, this means received power, has a large correlation. That means when a user moving in this direction, the received RS time serial data has a higher correlation with the locations. Use this property, we wanted to use a machine learning method to training the RSS time series data and location, and then use this relationship to realize and to estimate the user locations. This is our second proposed method. We have configured the evaluation scale area like this, which here we use 1, 2, 3, 4 LCX cables. And the user is moving in this route, and sometimes they have a random offset along main route. Use this environment scale array, we generate 8 hours RSSI data, and then use 75% for training and another 25% data for prediction. And here shows the localization accuracy. And we divide the area into two types. One is median area, like here, here, and here, and here. Another 4 area is called engine area. And our results, this result shows the total localization performance, and this blue line is a conventional TDOA method, and this one is our proposed method user neural network, and with different number of LCX, and shows a better performance. And this shows a different area. For example, in middle area, generally they have better performance than engine area. This is our second proposed method. And the third method, we found that if the user location has a linear relationship with time of arrival, and then the localization is easy to be realized. However, due to multipath fading and noise, generally the relationship is nonlinear. In such a case, we propose a method based on probability skew estimation. That means we use a particle field like this. And let me simply explain the process. The particle filter means that at first, we place particles randomly, and each particle represents the possible location for user. Then we use our TDOA and the system model to estimate its its likelihood. And using likelihood calculation, we decide which area maybe have a higher probability the user location will be there. And according to this likelihood, we resembling the particles. That means the place where the probably correct user will have a more particles, and then use the iteration process, we can improve its localization accuracy. Here, due to time limitation, I just give simulation evaluation results. This is for 2 dimensions, and this is for 3 dimensions. And this 2-dimension localized scale area shows that we can achieve about localization accuracy with mean error to 0.61 meter. And for 3D method, 3D localization scale area, we can achieve about 1 meter localization error. For the wireless LAN system, which worked at 2.4 gigahertz band and 5 gigahertz band. Okay, due to time limitation, I just simply explain major 3 items. First, I give a general introduction for LCX USH, and then how to realize LCX MIMO use 1 LCX cables. And then finally gives some introduction for how to realize localization accuracy for LCX-based wireless system. And thank you for your listening. And any question?
Thank you again, Professor Yafei. So I want to ask you if some of the people connected here have questions for you.
Okay.
Okay, I don't see any hands up. So I have one question, which regards basically the technology you are developing. So it's a very interesting approach for localization. My question is about electromagnetic interferences. So from what I understood, this system operates at 5 gigahertz, right? And
Yeah.
I'm wondering about if this technology can create interferences with other technologies that work in the same frequency range.
Yes. And I think that our research found that LCX can be used for many indoor cases. But of course, there are so many limitations because LCX cable seems to be price seems to be a little higher than monopole antenna. So it's limited its applications. But for MIMO technology, our proposal can largely reduce its cost and reduce the limitation of, how can I say, space for LCX configuration, LCX MIMO configuration.
Okay, so you are saying that your approach will reduce the cost in implementing this system in real scenarios.
Yes.
So I have another question, which regards basically the way that you use for implementing it in a real scenario. So you are going to install these antennas within walls, or
Yes.
there are okay. So very interesting, very interesting.
Thank you very much.
And do you think it will be helpful for? I mean, I'm thinking about consumer technologies applications like elderly monitoring. So do you think that, for instance, it will be easy in the
Yeah.
future to install this type of system within houses of elderly people?
I think that the localization maybe for consumer electronics is very important. In the future, I think the indoor case, there are so many device, and if we can find the correct location of them, we can provide many different good service for. I think that, of course, higher transmission speed is more important, is very important, but compared with the speed, location information is more important, I think, especially for consumer electronics side, consumer electronic research.
Okay, so from the perspective of the interoperability, so this system will it will be possible that this system will talk with other wireless systems like traditional 802.11 standard.
Yeah, our this is just the antenna. This antenna, our researcher for this system major operated over 2.4 gigahertz band and 5 gigahertz band, which is for wireless LAN system.
Okay, understand. Okay, so I want to ask again to people connected here if they have questions for you. Okay, so otherwise I will thank you again for this talk. So very interesting approach.
Okay.
I had a
And,
quick
Very
question.
much.
Okay, good, very
Okay.
good.
Sorry.
There
Yeah,
is
I'm
a
curious.
pause.
Are there
Please.
how, in terms of the industry partners or the companies that you may have interacted with to test out some of the viability here? You know, is it like companies like Belden or CommScope or on the antenna side? You know, who do you think, you know, would benefit from licensing this type of technology that already exists out there as an incumbent?
Yeah, I think I'm just a researcher and working for university. Of course, and this research is supported by Japanese government. So, how to make it for product? Of course, this is I have no idea about that, but I think that, of course, our research has been become a product and is now is in market and is sold by the Japanese company. So I'm sorry, cannot capture your capture your main question. You mean that the product or standardized or some other things?
Yeah, I guess I was curious about because I've seen some research at Cable Tech from the CommScope research labs around using not necessarily this type of technology, but another Wi-Fi protocol to detect, you know, the presence of a human, for example, in a room using these types of signals. So that I was curious if like a company like CommScope you thought might be a good application to bring it into
Yes.
a consumer setting or someone else. But yeah, I was just curious, just throwing it out there.
Oh, I see. You mean capture localization location use a
Yeah,
different
exactly. Yeah, capturing local location.
Of course, I think that there are many localization methods use a Wi-Fi or
Yeah.
RF signal. For example, use a monopole antenna. But I think it depends on case by case. For some specific environment, maybe some specific spatial antenna maybe have a better localization accuracy compared with some conventional antenna, especially for example for Palmer. And I think LCX can provide a very good localization accuracy for usage.
Got it. Thank you.
Thank you very much.
Okay, so there are other questions. Okay, so we can assume that there are no other questions. And I want to thank you again, Professor Yafei, for this very nice and interesting talk. And now we want to move to the other speaker.
Okay, thank you very
Dr.
much.
Luigi Celona. Thank you very much for your time. So now let's introduce the next speaker, that is Dr. Luigi Celona, who is an assistant professor at the University of Milano Bicocca here in Italy. So he holds a PhD and master's degree in computer science, and his expertise lies in image analysis, machine learning, and face analysis. So he has an associate editor for Springer 90, and he teaches C++ programming and intelligent consumer technologies here at the University of Milano Bicocca. So a prolific researcher, he's authored 40 plus articles and collaborates on international projects with various research groups. And today I'm going to talk about exploring image quality and aesthetics in consumer photography. So please, Luigi, share the screen.
Can you see my screen?
I confirm you that we see your screen.
Okay, thank you very much. Thank you very much, Paolo, for the nice presentation, and good morning, good evening, and good afternoon, everybody. And I'm Luigi Celona, and I'm gonna talk about this, let's say, new perspective, or let's say, comprehensive way of describing images and videos too. But let's start from the very beginning. The thing is that in computer vision, we usually try to mimic people in understanding the environment, namely trying to let's say see what is around us, and so perceive things and interpret things. And computer vision emulate somehow the vision, the human vision system, in order to let's say understand the world around us, but by using artificial intelligence and some features that can somehow catch the important things from the world. So essentially, algorithms are used to gather the characteristic of human vision and to generate models to emulate our capabilities. And the idea is that we have, for example, as in this example, a tomato that we can recognize, we can see through our eyes, then the brain recognizes it and give us, let's say, the interpretation of what we are seeing, let's say, a tomato. So the point is the computer can do the same, or at least we give it this capability by sensing the human world through vision. And so the point is, okay, in computer vision there are several tasks we know, but there are, let's say, three main tasks that researchers spend a lot of time in the last years, especially. And the first very important task is image classification, where given an image, we try to answer what's inside of the image, for example, a dog or something else. And so apart from this aspect, we can try to delve into the localization of some things into the object of interest into the scene. And this is the special case of object detection, where we try to localize instances into the main scene. And finally, there is a more accurate detection, let's call it in this way, of like segmenting all of the pixels depicting the subject or the object of interest, especially the silhouette and the body of the object of interest. So in this case, we are trying to, let's say, understand something about the semantic content of the images. And so according to this, we can obviously agree about the fact that in these two images, we have just on the left side an airplane, while on the other side an hamburger. Of course, these are I mean, the content of these two images is just an airplane or an hamburger. But the point is, we have other two images with still an airplane and an hamburger. Could we say something else or something more about the differences among the two airplanes or the two hamburgers? Of course, yes. And specifically, if we talk about perceptual metrics, we try to answer, let's say, complementary questions about the image content. In the specific case of the airplane, we try to answer the question, which is the best image in terms of technical quality? And obviously, we can complement the previous information of the airplane with further information regarding the fact that the airplane on the top of the slide had a low quality due to the presence of noise or blur, and also the presence of halo around the lights, while the last, the one in the bottom of the slide obviously has a very high quality, because we clearly say we can clearly see the airplane, and also the image is very sharp. Also, talking about the hamburger, we can let's say discriminate the two hamburgers in terms of aesthetics, because obviously if we take a look at the image on top of the slide, we agree that maybe it's not very pleasing. I mean, the hamburger looks like a mix of ingredients that are not well put into the hamburger, so it is not very let's say pleasing seeing, and is not very let's say. But if we take a look at the one in the bottom, instead we can say that the image contains a very high aesthetic hamburger, given that the light is very cool, and also the point that the ingredients are well shaped, and I mean the hamburger looks very tasty. So the point is, perceptual metrics are some quantitative measures that complement the understanding of the semantic content to assess semantic content according to human perception. So in this case, we try to develop algorithms that try to mimic the visual judgments and evaluate how well an image is perceived by human visual system. So in this case, we try to, let's say, not just focus on what's inside of the image, but on complementary aspects that can give us some new insight about the image content. And obviously, technical quality and aesthetics has two different, let's say, catch different aspects of the images. And specifically, the technical quality delves into the understanding of low-level degradations, such as noise, blur, compression, artifacts, that depends on different aspects, such as the application of the image acquisition pipeline, or some, let's say, environment conditions, and so on. While on the other end, the aesthetic assessment try to quantify the semantic level characteristics associated with emotions and beauty in images. So if we take a look at these two images, of course, we can see that maybe the one on the left got no very high quality in terms of the distribution of light, but in this case, the aesthetics maybe of the image is higher because of this lighting condition. So the two aspects, both technical quality and aesthetics, are strictly correlated and influence each other. So in order to, let's say, understand better which are the aspects that we try to model when we delve into the assessment of technical quality on one side and of aesthetics on the other side, we see that for technical quality, we try to understand if there is the noise into the image or if the image content is blurred, and also if the exposure of the scene is right one, if the contrast is correct or not. While for the aesthetics, we try to model some aspects that, let's say, are high-level features related to the composition. For example, some specific rules that photographs apply when they shot their photos. And in terms of which are these aspects, we can say that there are like some aspects related to composition or the style of the photography. So the point is, what we want to do about this perceptual metrics. Of course, the idea is that we would like to develop and design and develop automatic algorithms capable of modeling these aspects, and also to mimic the way people usually assess the images in terms of quality and aesthetics. And we do it by developing supervised algorithms that are capable, given an image, to map this image into a quality score or an aesthetic score, which represent the opinion of an extended sample of human observers. So according to this, we need to gather these opinions for each single image. That's why there is a first step of data collection consisting in some subjective studies where humans rate every single image that we would like to train or evaluate our algorithms in terms of aesthetics or of quality by using absolute category rating scales. So the idea is that given an image, for example, the subject is asked to give an opinion about that image, giving a score between 1 and 5 or 1 and 10. And so we iteratively collect this information for all the images for many different people, possibly with different age, gender, ethnicity, social background, to avoid any bias into our opinions. And then we average all of these opinions in order to obtain, let's say, a more objective evaluation or judgment of aesthetics or quality. Of course, if we have a very small sample, then it's possible that the judgments diverge or they are biased. So the idea is that when we have to collect a data set for image or quality assessment, in order to avoid the two subjective opinions, we need to have a very, very high cardinality sample of human judgments. So obviously, when we have data, then the final goal of both aesthetic and quality is to develop algorithms. And obviously, during time, there were several proposals. At the very beginning, of course, these solutions, these models were based on handcrafted features. So specifically designed for example, aesthetics or quality, catching all of the aspects that we intrinsically evaluate when we assess quality or aesthetics. But then, according to the advent of deep learning based methods, we try to directly estimate and understand which are these more effective features for modeling both aesthetic and quality by just analyzing data. So the idea is that also using deep learning models, we are capable not just to understand what's inside of the image, so it's not just image recognition, but quality or aesthetic assessment. And in this sense, we develop in our lab a solution both for the image quality assessment, relying on the use of deep learning model, and at the same time another model for aesthetic assessment, which is also capable of giving an insight of a specific decision about or a rate about aesthetics, because of course we have always to question about the algorithm about a specific choice. So for example, a giving score for our algorithm of aesthetic assessment is complemented with the information about the style of the photography, the specific composition of the image content. So the point is why this kind of perceptual metrics are relevant, and especially for the consumer technologies, why they could be, or how they could be applied. The idea is that in general, there are some aspects that we consider, for example, when we book our hotel, or for example, we have to order some the meal and so on. So in the choice process, of course, we have some aesthetic we make some aesthetic considerations for deciding what we want to eat, or from which host. So the idea is that we need aesthetics, for example, for developing ranking models that are capable of deciding which are the best images that can represent, for example, our shop or our hotel. And this is the case of study of several let's say websites that provide food delivery or reservation on the web. So the idea is that it's not something related just to the influence of quality and aesthetics in human choices, but aesthetics and quality are very important also for other aspects. For example, in some applications domain, it is important to have high quality contents. For example, in diagnostic imaging, it's important to have high quality contents because, of course, if we have low quality, then we are not capable to make the right decision about something. And the same occurs for automotive applications, for example, because in the presence of adverse conditions, for example, due to the presence of rain, or in this case of DAs, obviously it's not possible to apply the detection algorithms that should detect the obstacles into the scene. So it's important to apply quality algorithms that can enable us to, let's say, decide if the detector prediction is reliable or not. Also, the quality assessment is important in video surveillance for the same reason as automotive, but also because obviously if we get the presence of artifacts into the scene, then we are not capable of deciding if there is someone into the scene or not, or for example, if the stream of the video is correct or not. And this is the same for streaming platforms, where the use of quality algorithms is very helpful in order to decide, for example, the speed of the network, in order to provide the user the best experience in terms of the buffer that needs to be loaded. And so we need to keep a certain level of quality, of image quality, in this case of frame quality, for understanding what's inside of the image and avoid the blockiness effect and so on. And last but not least, the application of quality and aesthetics algorithms is very relevant in the smartphone and social media photography. Why? Because we take photos through our smartphone every day, and we are increasingly augmenting the number of photos that we shot with our phone. And of course, this is very important because when we have to, let's say, take photos with our phones, we need to have the higher quality sensors, but also some algorithms that can improve the quality of the shot. And so this is very important because we do something with these images that maybe is not as relevant as the images for diagnosis, but for example, because we post these images on social media, and we are somehow judged about the quality of our photos by the other people. And so that's why image quality and aesthetics are very relevant in smartphones because they can, let's say, help us in shooting, in improving our shooting capabilities, for example, because guiding the photo shooting automatically by using, for example, an aesthetic algorithm for deciding which is the best composition or the best lighting condition for catching a specific scene could help the final result and the final photo. But then we can also apply, let's say, offline a photo enhancement algorithm that is guided on aesthetics. So we have our photo into our smartphone or also on our laptop, and we can apply an automatic enhancement system that is, let's say, aesthetically guided in order to improve the aesthetic and make our photo more appealing. And we have already some solutions regarding, for example, the near duplicate selection based on aesthetics and quality. Because, for example, in my smartphone, I have this fantastic application that helps me to remove redundant contents based on, let's say, the matching of the contents that are very similar, but also by let's say, putting a star on the best one, the best of the near duplicates in terms of quality and aesthetics. So the point is what we should expect, or at least what we are expecting in our lab as the potential future challenges for quality and aesthetics. The idea is that of course, we are talking about the use of quality and aesthetics in the realm of consumer technology. So our idea is that maybe in the future we will use algorithm based on aesthetic understanding for improving IoT device capabilities. For example, for helping people in the best makeup, for example, on smart mirrors. But also, for example, for selecting the best outfit basing on some aesthetic features such as the color harmony or some other aspects. So in this case, we think that aesthetics might be very helpful for also IoT devices. But obviously, there is a problem regarding the fact that, as I mentioned at the very beginning of the talk, the point is that these models rely on the use of CNNs and deep learning models. And we know that these are very computationally expensive. So we need to, let's say, reduce the footprint of these models and also the inference time to run these models on, edge devices and very lightweight devices. So in this case, we need to reduce somehow and design new models that could fit into low power consumption devices and so on that are typical of IoT devices. So in the future, we think that quality and aesthetics will focus more on trying to design efficient solutions that are at the same time very effective. And finally, there is an emerging set of new, let's say, trends regarding where and how to apply, for example, quality assessment models. Because I showed you many different applications, but almost all of them regard the thing that we would like to use quality for selecting images and so on, but without a specific goal apart from improving the user experience. But the point is that the quality is also important for imaging, because as we said at the very beginning, the computer vision applications rely on the recognition of what's inside of the content, of the image content. So the point is that quality could be helpful in assessing the quality of the images for guaranteeing the reliability of detections. So we need to understand if after we enhance or we try to enhance the image content, we introduce some artifacts that can compromise the detection algorithm or something like that. Also, we can use a quality assessment for controlling retinal imaging and guaranteeing the reliability of diagnosis. And last but not least, quality assessment of portrait photos is useful to avoid exaggerating retouching that could cause loss of realism, but also, for example, avoid or fake the face recognition systems. So, in my opinion, these are very interesting topics that in the next future will be one of the topics regarding both quality and aesthetics. So that's all about my webinar. I hope that you enjoyed. If you are interested in our own solutions for both aesthetic and quality assessment, please contact me by email or consult. You can take a look to our websites. So thank you very much, and I will be more than happy to answer any question.
Thank you, Luigi. I want to ask if someone connected from remote have questions for you. Please, Alessandro.
Ciao Paolo, ciao Luigi. Hello, hello everyone.
Hello.
Just some consideration. I really appreciated your talk, also because it's quite difficult to point out the main highlights of one presentation in such a short amount of time in front of an audience which is also heterogeneous. So congratulations. From my point of view, you have touched a couple of topics which are quite one which is vertical, which is the translation of your of this kind of technology to the healthcare and well-being sector, which is quite important also because you know, when there is very subtle differences, for example, in terms of image processing, slightly different images, the one with respect to each other, which can distinguish from one subject who is pathological and one subject who is healthy. Your approach is, of course, quite important in this regard. And the second point is about the sustainability also from the environmental point of view, which should be one of our main drivers when we develop and adopt existing technologies in this regard. So I would like to know your feelings about these 2 points. So how will be the future trends in terms of the usage of this approach for healthcare and well-being, of course, and also when it comes to the future sustainability of such kind of solutions. Thank you.
Thank you, Alessandro, for the very interesting question, because I think it's, let's say, a broader problem is not just of quality and aesthetics, especially in the, let's say, for medical imaging, we always have to face the problem of the amount of available data, right? And in terms of let's say medical image quality assessment and medical imaging, the problem is that sometimes we don't have that many data, and this is, in my opinion, also a good and a starting point for dealing with the second challenge that you mentioned, like the green aspect and the lightweight development, the development of lightweight models. Because in my opinion, the point is that having a lot of data, of course, help us to let the model generalize to a lot of different conditions and so on. But at the same time, in my opinion, let us start with a very extensive training, and so this is very computational extensive and so on. And so in my opinion, the future would focus on still using deep learning techniques, but where it's not necessary every time to start from, let's say, a random models that need to be trained on specific tasks or specific data and a lot of data, because otherwise we overfit, we know. But let's say try to delve into model adaptation. So the main adaptation and something like that, in my opinion, can help us to, let's say, avoid extensive training procedures, and at the same time avoid the requirement of an high cardinality of, for example, labeled data that it's very impossible to have in the medical, I mean, from the hospitals and so for medical imaging. So in my opinion, the challenge is, okay, let's try to develop a model as effective as the ones that are trained on a lot of data, could be developed by using a few data, and also without not a very long time training, because otherwise, of course, we know that CO emissions increases and so on. It's not just the point of make the inference time very slow, very fast and efficient. It's also the aspect of avoiding a long training section. So in my opinion, in the future, we should, let's say, exploit the few data that we have in the best way as we can without extensive training sections.
Thank you, Luigi. Grazie.
Thank you for the question.
Thank you, Alessandro. So other questions? So actually I have one, which regards mainly the affordability of these methodologies in consumer devices with low computational capacity. If you have a comment on this, that could be helpful for this type of audience.
Thank you for the question. So the idea is, of course, we know that with deeper models, we almost all the time can achieve higher performance. But for example, for the aesthetic problem, very recently we saw some models that rely on the use of tiny CNNs. And so the idea is that if we focus on, as I said, delving into the usage of, let's say, small models and tiny models, could be very helpful also for the deployment of models on, let's say, edge devices or embedded devices with the low computational capabilities. So it's something that it's always it always relies on the trade-off between performance in terms of effectiveness of the model and efficiency of the model. So it's it depends on which is your final goal. In terms of development of the aesthetic model, you have to, at the very beginning, decide if your model will be deployed or must be deployed on a smartphone. And according to that, you will accept, let's say, the compromise of having maybe less effective model, but still that can be obviously deployed on a smartphone. So we know that the reality is that there are so many CNN architecture in the state of the art that some of them are explicitly designed for being deployed on embedded devices. So also for aesthetics and quality, we could exploit those models, those architectures, and not just using, for example, ResNet 15 or something like that, that are, let's say, very deep networks. And those networks are not obviously then cannot be deployed on embedded devices, but maybe can be used into a client server setup. But still, there are some privacy concerns because in IoT, especially, we have to take care of these aspects. So, in my opinion, the thing is that we need to focus just on tiny CNNs.
Sorry, I had some network issues.
Sorry?
I had to change. Sorry, I had some network issues,
no
so I
problem.
had to change my room.
No problem.
So I think that we finished. If there are no other questions, I want to leave the word again to Fabrizio. You are muted, Fabrizio.
Thanks again, Paolo.
Okay.
Thanks again to the speaker, to the speakers. We have been a little bit. We used a bit more time than expected, but I think the talks were very inspiring. So I want to thank again the speakers. I want to thank again the chairs of the technical committee and all the attendees. I think that the next talk will be in January. We still have to finalize the date, but you will receive communication through the mailing list of the technical committee. So once again, thanks, and let me wish you a great and pleasant and restful holiday season. Thanks again. Bye-bye.
Thanks again. Bye.
Bye. Bye.
Everyone.
Thank you. Wishes.